Greetings to the whole world. This is Luandile here, the leader and the instructor of Manikwe School. Today we're actually going to be doing exercise 2.10 from this textbook over here, in case you didn't know. So without any further ado, let's jump on to the question itself. So here is the question. We're actually doing exercise 2.10 as I've just said. Okay, so let's read it through. Write a program that calculates the energy needed to heat water from an initial temperature to a final temperature. Your program prompts the user to enter the amount of water in kilograms and the initial and final temperatures of the water. The formula to compute the energy is actually that, okay? Where m is the weight of water in kilograms. Temperatures are in degrees Celsius and energy is measured in joules. So we are also given a sample run. Okay. Okay. Without any further ado, let's jump on to our solution from student A's perspective. So student decided to have a scanner, call it input, equal to new scanner. In, and then we simply close our scanner. Okay, right in between we simply declare a variable, to hold weight of water, okay, called double. We declare a variable to hold our initial temperature. Is that even a correct spelling? I doubt it. What the heck is that? Temperature. Gosh. Okay, double initial temperature. Okay, and lastly we declare a variable to hold our final temperature. Okay, it's the E, not the A. Okay, double final temperature. Okay, what we then do, we simply prompt the user to enter the amount of water in kilograms. Okay, we then store that on our WW variable, which simply stands for water weight. Again, we do one and the same thing for. We simply do one and the same thing for our initial temperature. Enter the initial temperature. Okay, we simply stored in our IT variable input dot next, and finally we prompt the user to enter the final temperature. Enter the final temperature, simply stored on our FT variable, and put dot next. Okay, once we do that, that's where we actually get to the part where we do the computation. So we're gonna have to store our results on the variable called energy needed. Okay, we'll simply go, it's actually WW multiplied by our final temperature minus our initial temperature. We then multiply the whole thing by this value here, 418484. Once we do that, it is time to actually display system.out.printf. It is time to actually display the results. So let's see what we put here. We simply say the energy needed, that is, I hope everyone know this part, and if you don't, then I guess you're gonna have to watch my previous videos, because we've been using it for quite some time now. Okay, we then put the en variable right over here, energy needed variable. So with this out of the way, let me save this through and then hit the run button. Let's try to put the exact numbers they decided to put over here. So it's 55.5, 3.5 and 10.5. Gonna be 55.5, 3.5 and then 10.5. So let's verify whether this number here, 162548.4.0, is actually the same as this one. It seems like everything is the same. So it seems like our solution is actually working. Okay. So, I mean, now that we're done, you guys, I would really appreciate if you subscribe on my channel in case you haven't yet. And again, you can drop a comment. Like, I would really love to hear what this student might possibly have done wrong. Of course, I would really love that too. And again, you guys, as we all know, this is student A. So student A is perhaps actually the most dumbest student we have, because we've got 3 students, as we all know. So if you haven't subscribed on my channel, I beg you do. You can leave a comment again on this solution, like what you think I should have done differently. And you can put a thumbs up if you think this is okay. I mean, also you gotta feel free if you think this is not as good as it's supposed to be. So that's pretty much it, you guys. See you on the next tutorial.